Now we're next going to look at a couple more examples of the product of two binomials involving some radical terms. And as we did in our last example, we'll be using the FOIL method again. So we'll start off, in this case in part A, by multiplying the first terms of each binomial together, and that will give us 4 times the cube root of x squared. Next, we'll be multiplying the outer terms together. The outer product is what we'll be getting. And so 4 times the cube root of x multiplied by 5 times the cube root of y, but it'll be minus 20 then, times the cube root of xy. Then next, the inner product. And so that product will produce then 3 times the cube root of x. And then finally we multiply the last terms of each binomial. And that will give us, I trust you believe, minus 15 times the cube root of y. Now if we go back and look carefully at each term, you can see that none of them can be simplified further. Also, there are no like terms for us to combine together. So this then is our final answer. Now for part B, we'll multiply the first terms together to start off with. And that product will give us 16 times the square root of 25. And for the outer product, these terms multiply together will give us then 4 times the square root of 15. And for the inner product, these terms multiply together will give us minus 4 times the square root of 15. And finally, multiplying the last terms together, this will give us minus the square root of 9. So going back now to the first term, we'll have then 16 times 5. And I think you can see the middle two terms will add to 0. Then we have then minus 3. So 16 times 5 is 80, minus 3. And our final answer will be 77. Now take special note of the result in this case, that we started by multiplying some radical terms together, but we ended up with the result being a real number without any radicals. And also note that going back to the beginning, that the binomials we multiplied together were the same except for the sign between the terms in each of those binomials. And we call one of those binomials the conjugate of the other. So just take special note of that as we proceed further with this module, because this will be important for us when we consider division of radical expressions a little bit later, where the denominator is a binomial that contains a radical.